Right, you've probably got that note on your own screen. Just to say that we're recording the session, so if you have a problem with that, now is the time. Now is the time to leave, or to indicate the problem. But and this will become available on the IBH website after the session. We've got potentially 90 participants registered, 17 countries. So we're looking at probably 45 minutes of talk and then questions. And I would like to ask if people were prepared to put questions in the chat line as we go. That would be great. It is possible to come on screen at the end, but the chat line would be great to take the questions. And if anybody has a noisy background, please make sure you're muted. Okay, so I will introduce David. So David is I took a degree initially in industrial biology and a PhD, similar to myself, in plant biochemistry. And he joined what was then Paul's Malt as a senior research scientist in the autumn of 1990. And I remember working together. I was working at the same time. I think we possibly had a joint poster at the conference.
I think we both had hair then as well, Julian.
That's correct. Yes. So Paul's evolved into Greencore and subsequently bought Malt, and David had numerous roles in raw materials through to operations to brewer and distiller end use. He then spent some time travelling extensively, working in malting, and he joined Crisp Malt in 2013 as technical director, which is the position he currently holds. There are many responsibilities. When you're a technical director in a malting company, you've got to be pretty good at everything. So he's worked with plant breeders in new variety testing, technical malting projects, barley and malt quality control and quality assurance. He is an Institute of Brewing and Distilling diploma brewer, a Maltsters Association of Great Britain Master Maltster, and he's chaired the UK Malting Barley Committee. He's a malting diploma examiner, and he's written many technical articles. I can't think of anybody better to give this talk. So, David, I will hand the session over to yourself.
Julian, thank you very much for your kind introduction. I hope you've not beat me up too much here today. So I think 45 minutes might be a little optimistic. I would like to see this as a seminar where there's opportunity for quite a lot of questions at the end, questions that maybe other people are happy to chip into and give their points of view as well. So we'll move into presentation. This is the bit that the technical director normally fails on, which is sharing his screen. I'm hoping that you can see the presentation.
That's great.
That's great. Okay. So first of all, thank you for the to the International Barley Hub for the opportunity to give this presentation today, and equally for the MAGB for inviting me to speak. I'm really speaking here on behalf of the MAGB. As Julian said, I am the technical director at Crisp Malt, so I'm afraid you will see Crisp on the slides. So I thought the first really thing we should talk around a little bit is a little bit about malting. There may be some people on the seminar who are not that familiar with how we go about it and really why we go about this process of malting. And a lot of the attributes that we need in the barley are required in order for malting to be successful, but also those attributes then feed through into the requirements of our end user. So what is malting? Well, in simple terms, it's the partial germination of cereals. So this could be barley, could be wheat, could be rye, could be oats. In other parts of the world, it could be sorghum. Obviously, we're talking about the International Barley Hub, so we're going to focus on barley today, but we shouldn't forget that the UK malting industry does make quite significant quantities of malt from other cereals, wheat, rye and oats, going into the brewing industry and the distilling industry, and also into food. So it's all about controlling germination. So you'll see and hear that germination on numerous occasions through this through this presentation as being one of the main drivers behind quality. So in order to undertake that control of germination, then we can manipulate some of the conditions under which we hold the grain. So things which are in our control would be the moisture content of the grain, the temperature at which we're allowing the germination to proceed, and also to a certain extent the amount of time that we allow these processes to run for. And the consequence of putting grain through this malting process is that we produce a raw material which is suitable for further processing. So we're turning a material, in the case of barley, which is in its raw state, which is not that suitable for brewing and distilling with, but once we've processed it through the maltings, then we get this material which is far more suitable for our end users to use. In doing that process, we're adding value. So we're unlocking the extract, and we'll talk a little bit more about extract as we go through the presentation. We're generating enzymes necessary for our end users, and in certain cases, we're putting flavour and colour into the grain as well. So how do we exactly go about this process? Well, it's all about germination. So we need to take our barley, which ideally has been taken in at harvest time. So anyone who was on the call a bit earlier heard us discussing that 2021 winter barley harvest is underway, certainly in East Anglia. We're taking in the crop at the moment, where we'll dry it and we'll store it under safe conditions until it's ready to be malted. And then we need to wake it up. We need to get it germinating. So we do that by putting the grain into water to raise its moisture content up to a point where germination kicks off, and also where the endosperm of the grain is hydrated. That can take a couple of days in a steeping vessel, at the end of which the grain should be germinating and hydrated. And then we'll move that grain into an area where we can control its germination, where we can control its temperature and the duration at which we're allowing that germination to continue for. At the end of that process, we take all the water back out again. So we need to dry what is now green malt. We need to dry it down to fix the quality that we've achieved during germination, and also to make it stable for storage and transportation, and equally easy to mill by our end user. So in going through that process, we've gone from barley to malt. So we were grain into process operation, and we were grain out of process operation. But there's been fundamental changes occurred within the grain through that process, and we'll see a little bit about that in a moment or two. So the process of malting itself hasn't changed fundamentally, but the way in which we go about it has done. So if we go back more than 100 years, the majority of the malt being made around the world would have been made in floor maltings, of which there's only 3 now operating in England, but their evidence is in most towns. You'll see old maltings buildings. So here, this is our plant here in North Norfolk, one of the plants on this site I'm sat at today. So we maintain this plant from the 1870s. Quite a small amount of barley being processed at any one time, only 22 tonnes. So it goes through the steeping process, and the grain is then allowed to germinate on a malting floor. So this is a solid concrete floor, quite a thin layer of grain, requires quite a lot of manual intervention. The man there is pulling his rake through the grain to stop the grain from matting together, to allow some air movement, and to make to keep some control of temperature of the grain. So that was the predominant production going back certainly to the early 1900s. In the immediate post-war era, the Second World War era, there was a boom in building Saladin style malting. So this is pneumatic malting. So here the germination is carried out in this case, a cast concrete box. The grain bed depth is now probably about 80 centimetres, where on the floor maltings it was about 10 centimetres, and the grain is sitting on a perforated floor where we're blowing atemperated humidified air through the grain bed in order to control the process of germination. And our batch size has moved up. Now we're looking at about 100 tonnes of barley being processed per batch going through the maltings. And if we step up really into what is still the modern form of maltings, so this is a plant here again at Great Ryborough, built in the mid-1990s. This is now still a circular box for germination. This is now a 220 tonne batch process, all stainless steel construction where the grain is touching the surfaces. The vertical augers that you can see hanging off the machinery is effectively doing the job that the man with the rake was doing on the floors. So that's turning the grain and stopping it from matting together. And now our bed depth is over a metre high, so we're moving large volumes of air through the grain. So we're still steeping, we're still germinating, we're still kilning, but we're doing it on a rather different scale. And we're also doing it in a more mechanised fashion than we might have done. So just quickly looking at the individual steps. So all of this really has a bearing on some of the quality aspects of the grain that we need to process. So during the steeping phase, what we're trying to do is hydrate the grain. So starting at around about 12%, at that moisture content, the grain is stable in storage. It will maintain its ability to germinate. But we'll raise it from 12% up to the mid-40s. The actual target moisture content will very much depend on the type of malt that we're looking to make at the end of our process. So at that moisture content, the grain starts to germinate, but also the hydration of the endosperm results in the processes of modification. I'll touch on that briefly in a later slide. So it's all about modifying the endosperm. What we also need to do is make sure that we initiate uniform germination. So barley isn't an aquatic plant. It doesn't want to be kept underwater for long periods of time. So if we go back in time, go back again to our 100-year-old plant, our forebears would have been doing the process of continuous steeping. They would have put the grain underwater, maybe for 48 hours. They may have changed that water in that time period, but the grain would have been effectively underwater for that full period of time. At the end of which, when the water was drained, the barley would have looked like it was half dead, and it would take a couple of days to recover from that period of continuous immersion. What was discovered was that by putting the grain under immersion for periods of time and then draining that water and allowing the grain to sit in air for a period of time and then repeating that immersion process, then we were able to get to the same or higher moisture contents, but with reduced or with the grain now starting to germinate at this point in time. And that was a major step forward in processing time, as it allowed possibly a couple of days to be removed from the overall process time. So here we're seeing a 3-water steeping process, so 1, 2, 3 immersions. Now much more common to do a 2-water immersion. Modern barley varieties, we can get them hydrated with 2 immersions, and that obviously has significant benefits to our water usage and equally our production of effluent from here. So again, we'll come on to maybe some of the attributes that we would like in barleys, one of which being this ability to hydrate rapidly and evenly. So once the grain starts to germinate, we need to control temperature, and what we're looking for, this is really the heart of the process. So during the germination process, we're seeing synthesis and release of enzymes. Enzymes being released are breaking down the cell walls, getting rid of beta-glucan. We'll come on further to beta-glucan, certainly from an end user perspective. We're looking to increase the friability so that the grain is more easy to crush. The starch is accessible when the user starts to grind the malt and mash it in the distillery or in the brewery. We also see some limited solubilization of the storage proteins within the endosperm, and this is giving us soluble nitrogen and further breakdown of soluble nitrogen is leading to free amino nitrogen, and these are critical aspects for yeast nutrition. And again, there are differing requirements for those particular parameters by end users. So this is our classic picture of modification: release of enzymes, change to the endosperm. By the end of germination, the endosperm should be fully modified, and that has resulted in our change from barley into malt. As we've said, we control it by application of attemperated and humidified air. We spent 2 days putting moisture into the grain. If we blew dry air through the grain, we would just remove that moisture and the grain would dry out. So we need to humidify the air. So in terms of that change, I mean, if you take a handful of barley and a handful of malt and show it to someone who's perhaps not so familiar with it, they would probably say there's no difference in its physical appearance, external physical appearance. If you're able to crack that grain open, use an electron microscope, then you can start to really examine where these changes have occurred. So this picture on the left is barley endosperm. You can see starch granules. You can see the protein matrix. You can see cell wall material. And the changes which come about through the modification process are very visually apparent at this scale. So here we can see the freeing up starch granules, the removal of cell wall material, and the removal of the majority or proportion of the protein matrix. So the material on the left, very hard, compacted, very little extract availability. On the right-hand side, open structure, easily milled, accessible starch, full of enzymes ready to convert that starch in the early stages of the brewing and distilling processes. So our aim as maltsters is to supply the customer with a package of accessible starch. We're not interested in breaking the starch down. You sometimes read that in popular books about brewing. We might get 1 page on malting and 800 pages on brewing. The page on malting will say that the maltster breaks the starch down. Well, we don't break the starch down. We want the brewer and the distiller to break the starch down. We give them the starch and we give them the enzymes necessary. Then it's up to them to do the starch breakdown. So once we've got that level of modification, we need to stop it. So we halt the germination by drying. So we're taking the moisture down maybe from 41% down to somewhere between 3 to 6%, depending again on the type of malt that we're making. And in many cases, certainly for brewing, this is the stage where we're developing some colour and we're developing flavour characteristics that the end user requires. This is achieved by passing heated air through the grain bed, energy intensive process. The malting industry has been very good over the years at saving energy. We have opportunities at different points within the kilning process to reuse air or to recover energy from the air which is coming off of the drying grain bed. And the temperatures that we apply at this point will very much depend on the type of malt that we're making. We'll talk a little bit about that as we go forward. So, as we said earlier on, the quality of the barley that we're using has a major influence on how successful the outcome of our process is, and equally, those two factors contribute then to the quality of the malt which will go forward to our end user. So I thought it was quite interesting we've looked at the floor maltings. Life of a technical director in 1908 was probably a little bit easier than it tends to be in 2021, because malt specifications were somewhat different and somewhat reduced to the ones that we deal with today. So this I think I found some years ago in an old book at a maltings. This was the malt specification. I don't know what the brewery was, but it's Bryant's Analysis, and anyone old enough might remember Bryant and Harman as malt analysts, but this dates from November 1908. So our end user at that time was interested in extract. That's still today. I'm not sure what the units were, because 95.5 looks like quite a high level of extract. They're interested in how the malt was produced, grown slowly, which might infer they were interested in the malt that was coming from a floor maltings, because there was some debate at the point in time when pneumatic Saladin style maltings were first being used as to whether it was really malting or not. So maybe they're looking for floor malted material here. They're interested in the diastatic power. So that's the enzyme. The diastatic power is predominantly beta amylase. So the enzyme that will give us high levels of maltose and high levels of fermentability. They're obviously interested in colour, quite a high colour here. Beers have become progressively lighter over the intervening years. Matters soluble, I think is cold water extract. So this is the pre-formed soluble extract that would be available. That looks quite well modified at 21%. And interesting, there was already an interest in food safety. So they're looking at arsenic. So there had been a scare in Manchester in the late 1800s with beer that was contaminated with arsenic, which was traced back to the malt, and which was then subsequently traced back to the fuel, the coal, that was used to fire the kiln. So interesting that the food safety featured on the specifications as long ago as 1908. And then, of course, moisture, 3% maximum moisture. So if only that was where we were today. Today, we've got a longer list. So potential items that we could see in a malt specification today would still include extract. We're measuring extract on all malts that we're making, be it for brewing or for distilling. This is the key. This is where the starch is being broken down into soluble sugars, fermentable sugars. Other material also is being extracted into the wort at this stage. Moisture, everyone's interested in moisture. No one wants to buy more moisture, more water than is necessary. Colour, critical to the brewers. Colour, but also then after boiling as well. The nitrogen measurements, both the total nitrogen of the grain, the soluble nitrogen of the grain, and then the ratio of those two factors, the amount of free amino nitrogen also. Arton measurements is quite Middle European, but again is looking at the breakdown predominantly at that temperature of 45 degrees of nitrogen. We might be measuring fermentability as final attenuation, and the list goes on. We'll be measuring enzymes, DU, DP, perhaps even beta-glucanate activity. We'll be looking at cell wall, work viscosity, beta-glucan levels, friability, Holcom's, staining with calcofluor to look at the fluorescence of cell walls under a UV lamp. We'll be looking for dimethyl sulfide in beer, in malt for beer. For distilling, we'll be looking at how much spirit, how much alcohol is going to be produced. We might be interested in the gelatinization temperatures of the grain. We'll be looking at nitrosamine levels for food safety, similarly with glycosidic nitrile. There's interested in lipoxygenase for staling, grain size, dust. The list is endless. This could have been multiplicity of slides on this. So I think a malting or brewing chemist from 1908 would recognise some of the work that we're still doing, but they would be slightly perplexed probably by some of the other things that we're doing. And the reason why we're asked to carry out this level of analysis, this level of characterisation of malt, is that the quality of the malt can have impacts throughout our end users' process. There's certainly around milling and mashing, both in the brewery and in the distillery. Come on a little bit more to that as well. The ease with which that extract is obtainable is critical. Certainly influencing fermentation performance, again, both in the brewery and in the distillery. The composition of the wort have a major impact on that factor. In brewing, we can get some issues with quality in beer maturation, infiltration of beers. If there's beta-glucan hanging around, that can influence filtration runs. Certainly in terms of product flavour, any off flavours that are in the malt could come through into final products. But also we're seeing increasing interest in flavours which are coming from malt. We can come on to that as well. Product appearance, hazes, It could be also, shelf life stability comes into this area as well. So, and wholesomeness, certainly from a food safety perspective. So the maltster has the opportunity to screw up their customers' processes at just about every stage if we don't get it right. Hence the scrutiny, and correct scrutiny, which malt undergoes when it leaves our plants and when it arrives at our customers' plants. So we just step back a moment into barley. Then we have some contractual requirements which we require the barley which is being delivered into our sites to meet. And this is fairly common across all maltsters. So the first and foremost really is that we are contracting and receiving an approved malting barley variety. Now this could be a variety which has been approved through national testing systems. So in the UK here we're talking about the Malting Barley Committee system. In other countries it could be the Berliner program. In Germany it could be Danish preferred. It could be the CBMO process in France. So we have customers that will accept malt from varieties which have been approved through those systems. We also have customers that have their own particular varieties, which haven't necessarily been anywhere near the official testing process, specific to particular customers, required because they are required for that particular malt type, for that particular brewing or distilling process. First and foremost, in terms of testing that we do on barley coming onto our sites, is to make sure it's alive. Our process requires the grain to germinate. We need highly viable grain. So that's a minimum of 98% of the grains within the sample taken from the load assessed must hit that 98% number. There's no negotiation around this parameter. So if it doesn't make 98, the lorry is turned around and sent away. So this is measuring, is it dead, is it alive? And we'll come on to some of the other germination requirements a little bit later on. The other thing we need is an appropriate level of nitrogen or protein, as it would be termed in other parts of the world. So there's no right or wrong here. It's really what's appropriate to the type of malt that we're needing to make and what the end user's requirements are for nitrogen. We don't want lots of small grains. We want big, bold grains. These small grains tend to process differently through the maltings. They take up moisture very rapidly. They don't have a lot of extract, so we screen the grain before we process it. So clearly we don't want to have a lot of small grains which won't enter the process that would go off for animal feed. Obviously there's a penalty there if we're seeing those small grains being delivered in loads. We want barley delivered. We don't want other admixture. So we will have maximum admixture specification. Equally, we don't want peas and beans or maize or any other cereal. We don't want bits of combine harvester, ideally, or any other material that may find its way into a load. Clearly, we don't want grain which is mouldy. We don't want smelly grain. So all loads will be assessed for that parameter as well. We may do mycotoxin testing at intake as well. As we said, we're now at the very early stages of 2021 harvest, so we will be checking samples at this stage for mycotoxin levels, particularly for dioxin of alanol, field mycotoxin, just to get an indication as whether there could be any issues with this crop. But we don't want mouldy or smelly barley. And we don't want a lot of damaged grains either. So we don't want a lot of skinned grains, we don't want a lot of split grains, and we don't want a lot of half corns. And we can talk a little bit about that as we go a little bit further on. So we want a good, wholesome sample, and we'll check this on every load of barley that comes onto site. So this malting's here. We're producing 115,000 tonnes of malt a year. So we're taking about 130,000 tonnes of barley. And every 28, 29 tonne load will be checked for these particular requirements to make sure that it meets our needs. So in terms of approved barley varieties, it's interesting to note that the process in the UK splits out varieties by use, so and also by type, be they winter varieties or spring sown varieties. So brewing use, we've got 3 approved winter barleys. This is crop 22, but it stands for where we are today. So Flag and Craft and Electrum approved brewing, and for brewing use, spring varieties, Planet, Laureate, and Diablo. Some in process, and those of you that are familiar with the Malting Barley Committee will know that these varieties are undergoing commercial testing at the earlier stages with a view to them gaining full approval in the fullness of time. For malt distilling, interestingly, no approved winter varieties. We'll come on to that in a moment. For the spring varieties approved for distilling, Laureate, Sassy, and Diablo. So we've got crossover here between brewing. So we've got this phenomenon, or a fairly recent phenomenon, of dual purpose varieties. So Laureate approved for both brewing and distilling. Diablo also approved for brewing and distilling. And this is all around the glycosidic nitrile character. So Planet, for example, very successful brewing variety, picked a good name because it is being grown across the planet. It's probably the most widely grown malting barley variety across the world. Isn't approved for distilling because it produces glycosidic nitrile, so it was never approved for malt distilling use. For grain distilling, we've got 1 approved variety, Fairing, and again we can come to grain distilling in a moment. So the other thing on that list was not only the variety, but it was getting the appropriate nitrogen content. So as we've said, there's not really a right or a wrong. I mean, we don't want it too low. We don't really want it under maybe 1.2% nitrogen. We probably don't want it much above 2.2% nitrogen. But in that range, there are requirements for barleys for different tasks. So this is the Maltsters Association of Great Britain members wish list. So this is what we will be looking for as an industry from the 2021 barley crop. We'll be looking for around about 1.8 million tonnes of barley out of England and Scotland, producing about 1.6 million tonnes of malt. And you can see there is a clear distinction geographically around the nitrogen requirements for this barley. So in southern England, which is where a lot of the winter barley is being grown, we're looking at relatively low nitrogen levels, under 1.6 in the winter barley. So still quite a lot of Maris Otter being grown here. We've seen 21 crop Maris Otter samples in the last few days. The spring barley here, the requirement here is for a little bit higher nitrogen. This would be for use in some of the global brewers' demand for UK produced Pilsen malt, might also be used for export malt to other parts of the globe which are looking for a higher nitrogen content as well. The lower nitrogen spring here is potentially going for distilling production in England. We don't have enough malting capacity or barley in Scotland to fulfil the requirements of the malt distilling industry. So we will see barley moving north and potentially also malt. And that's quite more clearly in the north of England picture with some lower nitrogen requirement for lower nitrogen spring barley. And if we move into Scotland, you can see that Scotland is dominated by the requirement for low nitrogen spring barley for distilling use. The higher nitrogen portion here, really across all areas, would be for grain distilling for high diastatic malt production. So we've looked at our contractual requirements for barley, but there are some more desirable attributes that we really want in addition to just what is straightforward to contract, or perhaps what is we can measure things contractually. This is really what helps us turn that barley into good malt. So it's really having that appropriate quality potential, a bit of an airy-fairy kind of statement, but it's the combination of the right variety, it's the combination of the right or the appropriate nitrogen or the right nitrogen content for the type of malt that we're going to make. It's really being able to turn that into the malt type that we want to produce. So we would include things such as having low dormancy. So we've assessed the grain at intake to make sure it's alive, but at this time of year that grain will be alive, but it may not be willing to germinate. So we've got this natural phenomenon of dormancy. So we have to normally wait for the new crop barley to recover from that dormancy. So even though we're taking barley in today at this site, that barley probably won't be ready for malting for another 6 to 8 weeks, depending on the level of dormancy. We'll start to assess that. We've got tests that we can carry out to assess that dormancy. So the consequence of that dormancy phase is that we have to continue malting old crop. So we'll continue malting the 20 crop into September, October. So each crop year, effectively has to cover 13 to maybe 15, even 16 months of processing while we await the new crop recovery. So we have this issue of requiring ideally low dormancy. Water sensitivity is another element where even though the grain looks like it's satisfied to come out of dormancy, ready to grow, it may not want to grow particularly well under some of the conditions that we're going to expose it to in that great big steep tank with an excess of water. Problem with dormancy is that there's a flip side to that. If we drive dormancy in barley varieties down too low, then we run the risk of pre-germination, and the grain already starting to germinate on the ear before it comes even through the combine harvester and comes onto site. So we'll assess pre-germination in those loads that we're sampling and testing. We can use the same test that we use for germinated capacity to also evaluate pre-germination. And touch wood, we haven't really seen any sign of pre-germination this year. Threat of rain at the weekend makes me a little bit nervy with high temperatures that we could perhaps move into a time when we might start to see a little bit of pre-germination coming through. We want that even grain size. So even grain size means even rates of hydration during steeping. It means even rates of modification. And when it gets into our end users mill, it means nice consistent milling. So we've spoken about ease of moisture uptake, where we've probably moved from varieties needing 3 periods of immersion to 2 periods of immersion. Can we get to a point in time where barley varieties only need a single immersion? And that would certainly help in terms of water requirement for malting. Not just germination, everything proceeding at the same rate. A lot of what we're doing here is trying to control the homogeneous or the heterogeneity which is inherent within our samples. If you take an ear of barley, take the individual grains off, measure the individual nitrogen content, you will find quite a spread of nitrogen content even at that stage of the process. So from that point onwards, all of our actions is really to make sure that we keep the process, the product, as homogeneous as we can. Husk retention, very important. So very important for us, very important for our end users. We've seen a tendency in over a period where varieties coming forward were tending to shed their husk. So skinned grains take up moisture very rapidly in the steep tank. If we've got a proportion of skinned grains, then they will modify differently. It'll absorb moisture more rapidly. They will go through the process behaving differently to grains which have retained their husk. And then the husk is very important for our customers when it comes to wort separation after mashing. So clearly they want that husk available as well. So measurement of husk retention in new varieties is now quite a significant element of their evaluation to make sure that we're not bringing forward varieties which may start to shed their husk. We certainly don't want any food safety risks associated with the barley, with our process. So hence the emphasis on mycotoxin measurement. the emphasis on the measurement of agrochemical residues. The MAGB runs a due diligence scheme that we all contribute to in order to assess the UK crop and to demonstrate its safety in terms of malt production and then malt usage. So those elements of those desirable attributes really impinge all the way through sort of the production of the malt, some of the attributes that malt is going to have going forward to our customers, and clearly also, you know, food safety risks throughout the remainder of the food of the supply chain right into the customer's glass. So we've already seen the process and some of the time. So where do some of those aspects come in? So we've talked about dormancy and our need to balance dormancy against pre-germination, the advantages of even grain size, the uptake of moisture, the importance of husk retention. They're all going to be quite important to how we go about steeping the grain. And then we'd like the grain to germinate quite rapidly. So we would normally run germination processes for around about 4 days. Some of you may know that as a company we have a heritage project, and the older varieties that we're malting often need up to 6 to 7 days of germination in order to achieve a satisfactory level of modification. So again, the breeding process has shortened the malting process down to a level where we can achieve satisfactory quality in a shorter period of germination. Then when it comes to kilning, you know, we need to get the moisture back out of the grain, so we need an easy moisture loss. Ways in which dimethyl sulfide can give us cabbagey flavour to beers. We can control that in kilning. Can we lose the DMS more easily? Can we see barley varieties which can assist us in this process? Control of lipoxygenase with the risk of staling. Can we control that easier than necessarily having to control it by kilning? We need to preserve enzyme activities, and clearly we need varieties and barleys which give us satisfactory colour and flavour, varieties that don't colour too quickly, and we can control the colour formation. So we talked about, for the maltster, talk a little bit now about what our end users are looking for and what's important to them. So for brewing, extract potential. So this is an economic parameter. This is where the alcohol is going to come from. This is derived from the starch. So obviously higher extracts are desirable. Extract isn't only fermentable sugars. There's other material in there as well, but we measure it as an increase in gravity of the wort, and that's taken to be indicative of the extract potential that the brewer will see. It needs to be processable. So processability is very important. So we need malt with low beta glucan, malt that will produce a wort which has low viscosity, is easy to move around the brewery. We need low beta glucans when it comes perhaps to beer filtration, so that we can maintain lengths of filter runs. And generally anything which impacts on cycle times is perceived to be detrimental. And you know, that's a very important measure of the efficiency of how the brewery is running. They need the right amount of nitrogen for the type of beers that they're looking to produce. And we'll come a little bit onto that in a moment. And also the impact that malt could have on final product, and that could be in appearance, it could be in flavour. So for the malt distiller, it's all about alcohol production, or for most distillers, it's about alcohol potential. Again, coming from the extract. Processability, similarly, we don't want any issues in mashing or issues in the draff, the residual material. We don't want beta glucan causing moisture to be held up in draff. We definitely need low nitrogen here. This is low nitrogen drives our alcohol potential through its relationship to starch within the endosperm, and a critical parameter now is the fact that the malt must come from barley varieties which are non-GM producers. In grain distilling, enzyme potential here is king. So we're looking here for high levels of enzyme to convert the non-malted cereals which are used within the grain distillery. Again, processability here is another key factor. And here we're looking at high nitrogen in order to give us the scope and the potential for that high enzyme levels. And again, we need the barley to be a non-GN producer. So as we've seen earlier on, the previous seminar was talking about the recommended list. So the Malting Barley Committee comes into play at recommended list level for new varieties, and all these elements are being evaluated, firstly at a micro malting scale, and then secondly through commercial brewing and distilling trials, in order that we bring forward new barley varieties which are going to meet these requirements, they're going to meet these expectations that we have both through malt production and also for our end users. So look a little bit more detail at brewing. Then we spoke about extract potential. We said this is where the fermentable sugars are going to come out of. This is where the ABV, the alcohol, is going to come through from. And this still remains one of the main selection criteria when new varieties are being introduced into the system. And we were quite when going briefly back to our heritage again, when we first malted and analysed Chevalier for the first time in well over 100 years. The analysis showed that the only deficiency it had in comparison to a new variety was extract. So the breeding process over the intervening years has really focused on extract and bringing that up to a really satisfactory level for brewing with. Processability, we don't want to impact cycle times. So we want the malt to mill effectively, we want it to mash effectively, and we want the runoff from the mash tun or from the lauter tun to be within the required time. And this is really where our customers are measuring their efficiency, and they're coming back and assessing our performance as maltsters as to whether the malt we're supplying with them meets their process requirements. The nitrogen requirements really differ. So all malt brewing, 100% malt in the grist, requires a level of diastatic power, a level of enzymes which are there, which are sufficient to convert the starch which has come into the mash with the malt. So traditional UK ale brewers are looking at maybe nitrogen contents up to 1.55%. This year we're seeing some lower values than that in the crop that we're harvesting at the moment. Whereas if you're maybe a global brewer, you might be using some adjunct, some unmalted material in your mash. So that unmalted material doesn't have enzymes associated with it. So the enzymes in the malt need to be higher. So that would come through some higher nitrogen malt. Also, the adjunct doesn't have things such as soluble nitrogen and free amino nitrogen, which are required for yeast nutrition and again, successful processability. So that has to come from the malt. So they're associated with higher nitrogen barleys. So you tend to find that if brewers are using higher levels of adjunct, then they're looking for malt with nitrogen contents above 1.65%. Total nitrogen could be up to 1.9 levels, depending on the amount of adjunct and the type of brewing and the type of beer which is being produced. The last one here was just really the impact on final product. So flavour. The flavour now is a hot topic. Flavour of barley varieties and their contribution through to the final product. A lot of the craft industry very focused on flavour. We've seen hops being a driver. We're now seeing flavour from malt being assessed and being seen to be distinct in barley varieties. So there's an opportunity here, to start looking at the impact of flavour that comes directly through from the barley. Visual appearance as well. I mean, the malt could contribute to haze in that final beer. You might want haze in your final beer. It seems to be a popular route these days to have hazy beers. So maybe you want it to be hazy. If you don't want it to be hazy, then clearly your malt needs to be assisting you in producing a product which is haze free and very bright. So moving on to malt distilling, alcohol potential very important here. So product of extract and fermentability. Again, this is the key determinant of distillery efficiency. Processability, good husk retention, again for good wort separation, good extract recovery. So we need to be able to get all of that fermentable extract out of the mash and into the fermenter in order to get maximum alcohol yields. Here, low nitrogen, so we need varieties and we need malt which has got a stable low nitrogen accumulation. So we're looking at here ideally at nitrogens probably under 1.5% in a typical year, but as low as possible. That will really maximise the extract potential within the barley, within the malt. And also then, yes, non-GN producer. And this is where we're seeing this dual purpose variety development, so varieties which are suitable for both brewing and distilling. Good for the maltster. We can take the higher nitrogen of those varieties and use it for beer malt production. We can use the lower nitrogen for distilling malt production. So for grain distilling, then we need enzymes to convert the raw cereal. So let's say that 10% of the grist composition is from malt. So we need to maximise the diastatic power and the dextrinizing units in order to get maximum conversion of the unmalted cereal. Again, processability here. A lot of interest around soluble nitrogen and also FAN, free amino nitrogen. Again, to compensate for the lack of those attributes within the unmalted cereal and really driving to maximum alcohol yield. High nitrogen barley, high nitrogen malt is associated with maximum enzyme potential, and so very much quite a niche product. So we're looking at varieties which can accumulate high nitrogen and also varieties which can maximise their enzyme potential. And then again, as per malt distilling, then we need that grain to be a non-GN producer. So we have some opportunities for innovation in malting, which will knock through to our end users. So clearly, a big focus at the moment on sustainability and reduced or ideally net zero carbon footprint, so a drive towards barley varieties with very low agronomic inputs, varieties which can help us achieve this drive to net zero carbon. Husk adhesion, we seem to be back to a better position on this with new varieties. I think the message got through that we need adhering husk. Rates of hydration, we're seeing some varieties which seem to modify well relatively low moisture contents. So again, this is another opportunity for our industry to reduce our water consumption as part of our sustainability agenda. So this low moisture modification would be a goal. As I say, we're seeing that from some plant breeders' material. Low beta-glucan content. So our task as maltsters is to get rid of the beta-glucan because there's very little scope for further beta-glucan reduction when we get into mashing. So maybe varieties which are going to give us that constant low beta-glucan. Null DMS, controlled on kilning. We are seeing varieties now coming through which have this null DMS potential. Maybe allows us to dry our kilns to a slightly higher moisture content. Again, good for carbon footprint and energy consumption. Higher enzyme content, a requirement for some brewers, certainly a requirement for grain distillers. And improved enzyme stability, more temperature stable enzymes would be useful. Certainly stable beta-glucanase could have a role. 6-row malting varieties. I think back in the day, probably when Julie and I were first starting, we did have 6-row malting varieties in the UK. Disappeared quite quickly. A lot of use in other parts of the world. Not seeing them yet in the UK, but we are seeing some varieties coming into the testing system. Tend to be higher enzyme varieties, may be more suitable for certain malt types. And then flavour. So can we breed for flavour? Maris Otter, 56th harvest this year, second biggest winter barley in the UK in terms of volume. People say it's because of flavour. So should we be looking at evaluating new varieties for their potential flavour contribution? So some of these come through. These what's good for the maltster is generally good for the end user. So a lot of brewers would all love lower beta glucan, maybe higher FAN for some applications. Noel Locks has been around for a little while, keen on it. Some brewers keen on it, others not showing quite so much interest. But when we start to see that this come through as a character, then maybe other brewers will start to show interest. And as we've said, flavour. What's the interest there to focus on flavour, and then stability of enzymes. For the distiller, should we be looking at winter varieties? Should we be evaluating those? We do now have a non-GN winter variety, which is being grown in reasonable volumes now outside of the testing system. What's the scope for winter varieties for distilling? Higher yield. So if you're measuring your alcohol production per hectare, then potentially you've got some benefits there, benefits to land use, and some gain there through to perhaps hedging also around crop conditions and crop quality. Distillers are interested in flavour, so does all the flavour have to come from the barrel, from the wood? We know that different varieties give different flavours in new make spirit. Can those flavours be maintained through to the final product? Clearly, non-GN producer is an absolute now for any new variety of barley and malt. Grain distilling, how can we boost enzyme potential? UK high DP varieties are not as good as high DP varieties from other parts of the world. Can we work on that? Is it related to to latitude at which the grain is being grown? Do we need better adapted varieties for the UK in order to achieve those higher enzyme potentials? Enzyme stability would be good. Higher, more thermostable beta amylase. Will we get better fermentability as a consequence of that? And then non-GN producer, of course. Not forgetting our food users, really. Naked barley. Should we be malting naked barleys for use in food? Husk barleys are not that nice to eat. Naked varieties are much more pleasant. Flip side of beta glucan for food use is soluble fibre. Could we contribute soluble fibre into food use? Can we manipulate nutrients through malting of variety to make it more attractive as a human food material? I think final slide. We do have opportunities for innovation in barley attributes, which will come through into both malt production and also into end use. Extract does remain a key. Other attributes are of increasing significance and get more scrutiny than perhaps they might have done maybe 10 years ago. Where can we get innovation from? This is one for the plant breeders, one for the International Barley Hub. Should we be looking at more obscure germplasm? Going back to old varieties, heritage varieties, what mutagenesis or genetic techniques will we be allowed to use in order to bring forward some of this innovation? Right, I'm going to shut up and wait questions. Julian, back to you.
Well, David, thank you very much. It was a big topic, and you did well to cover it in the time that you had. So there have been a number of questions coming through. One just comment of mine is when you look at the research, the opportunities for innovation, we really need a Barley Hub, because there's a research pipeline there that's going to go for the next 20 years.
Absolutely. Anyone know one that's coming on stream?
I'm going to go to the questions because there's been a few questions coming in on the chat. So the first question is from Pete Headley, and he asks, what are the primary qualities which might promote winter varieties to be recommended for distilling? And before I hand the question over, I would say, Pete, if you look at the Malt project, which was a James Hutton project, that's got quite a bit of detail on this. But David, do you want to just summarise quickly?
Yeah, absolutely. I mean, for distilling, we keep banging on about non-GN. I mean, that's got to be the first factor. It has to be a non-glycosidic nitrile producer. After that, then it's clearly another driver. Another key driver is the potential, the predicted spirit yield. Just how much alcohol can you make from 1 ton of malt that goes into the distillery? Now, historically, winter barleys have been behind spring barleys in their predicted spirit yield. The non-GN winter barley pipeline, which we're seeing, is bringing forward varieties with improved predicted spirit yield, not necessarily quite matching those of the spring barleys. However, as I alluded to, there is the calculation around the fact that you can produce more winter barley per hectare than you can spring barley. So from a sustainability point of view, maybe not so much from a distilling point of view, because the distiller's potentially going to have to put more malt in to get the same yield at the moment on these sort of early generation potential winter malting barleys. But from a land use and sustainability point of view, then that might be attractive to distillers in terms of the amount of land which is being used to produce the malt for the whiskey that they're producing.
Okay, but certainly, Pete, look at the Malt project. There's a lot of detail on that topic.
Yeah, that's where a lot of this has come out of.
Yeah. Then we've got a question from David Mitchie at NFUS, and this is kind of pointing us towards the next lecture, actually, but you might want to just comment briefly, David. David says, as we move towards low carbon net zero farming with less nitrogen fertilizer and more fixed nitrogen from intercropping or from previous crops, this will very likely have a knock-on effect on grain consistency and quality. How can farmers work across the supply chain to tackle this challenge? It's a big question.
Yeah, that is a big question, a good question. So we're working with our group of farmers, understanding, their approach to some of these aspects. Certainly, we're seeing quite a lot of intercropping, and we're seeing quite a lot of cover crops going down before our malting barley is going into the ground. And yeah, we'll see a downward pressure on application of artificial nitrogenous based fertilizers. So I think it is something that we're going to have to monitor. We've seen a situation in Denmark where there was a this sort of predates a little bit sort of the stain. This is more around nitrate runoff into watercourses. We saw a restriction on the amount of nitrogenous fertilizer they were able to apply in Denmark, and we did see a decline in the protein content of malting barley that was coming out of that origin. So it is something that we're going to have to keep a close eye on and strike that balance between being able to fulfill our obligations in terms of nitrogen into our end users, equally fulfilling our obligation in net zero.
Okay, and David Thompson asks, and this is a question about distilling varieties and glycosidic nitrile. So how do you approach the requirement of low or 0% glycosidic nitrile content in the newer recommended varieties with that of the older varieties with relatively higher GN like Maris Otter? And I know this is an interesting question because I believe Chris, of course, sell Maris Otter barley.
We do. So some of my distilling friends might be on the call and might be better able to answer some of this than I am. So glycosidic nitrile is not an issue for all distilleries. There are certain elements or aspects within the distilling process which can influence how important like the glycosidic or the zero glycosidic nitrile character is for that particular distillery. So yes, distillers are using older varieties which will produce glycosidic nitrile, and I think there was always an element of caution projected to them in this, making them well aware of the fact that they're not the same as the laureates and the Diablos and the Concertos that have been, used for mainstream distilling over the years. So I think that would be my sort of main point, really, to just to make sure that people are aware of the fact that these varieties don't have that, or they do have that capability to produce glycosidic nitrile. And then it's really over the distiller to make that decision as to whether he's happy to proceed on those terms.
Yeah. Okay. The questions are coming in thick and fast, so we'll plough on. Right. This is an interesting question. What percentage of the barley harvest fails against the various criteria? And for batches that fail, and so they fail to make the grade for malting, what alternative uses or disposal options exist?
Right. So this is barley that wouldn't make the grade.
This is barley that's rejected at intake.
Okay, barley that's rejected at intake would go into the feed usage. So obviously we're looking to reject as little barley as we can do, and the major source of rejection would be around germinating capacity. So that is, as we said, that's the only thing that we will absolutely reject. On the other elements, the nitrogen, the screenings, to a certain extent, we will negotiate maybe a price reduction on that, but we'll do our utmost to accept as much barley as we can. I mean, as a business, we will still pre-screen purchase samples in order that we can make decisions before the grain arrives on site, to reduce some of the costs within the supply chain, to prevent a load coming and then being rejected as far as we can. But I think, Julie, I'd be right. As an industry, when our rates of rejection are quite low.
Yeah, and I was going to say as well, that was from me in Sutherland. Look at the Maltsters Association, the MAGB website, because we publish sector data on rejections and also what we reject for. So you can look year on year what barley is being rejected for. So the next question comes in from Klaus Oldak. So for brewing, mixing of different malts from different varieties, is that common or is that a no-no? And out of experience, are there years where there is an undersupply of suitable barley quality?
Well, that's another interesting question. Again, it depends who you are. So there's one major global brewer who must have two varieties supplied to them. There are other major brewers who will only accept a single variety. There are some, brewers which are happy to accept spring barley and winter barley blended together. There are other brewers who will only accept spring barley. So, I mean, from a maltster's point of view, having the greatest flexibility of blending of varieties allows us the greatest opportunity to meet the malt specification. So it is very much a personal choice of the particular brewer that we're working with. Obviously, if we're supplying Marisotta, it's Marisotta. So there's no blending there. If you're supplying a named variety as the malt which the customer's taking. Tend to see a little less blending in distilling. Generally, it's single varieties quite often because the distilling marketplace is dominated by a single variety. So we had a long term with Concerto being dominant. We're now into Laureate being dominant, and generally it's a single variety going into distilleries.
Yeah, this is a great discussion over a beer at a brewing conference. There's been many a discussion about mixing of.
Yeah.
Okay, the next question is: barley variety selection a consideration in the production of gluten-free beers?
Not at the moment, I think, is the answer to that one. I mean, a lot of the gluten-free beers come through enzyme treatment within the brewing process in order to reduce the gluten that's available. We have seen one reduced gluten barley that's come out of Australia, I think I'm right in saying, and that has gone into production. But I think it's an area that is going to get more attention. I don't know of European plant breeders that are working on that. So yeah, and a lot.
Interesting topic with using alternatives to barley, of course, using oats and wheat.
Or reducing your barley malt proportion within the grist, using rice or some other non-gluten containing cereal.
Okay, I've got a question here, which is I think this is looking to the future. So recent extreme weather conditions at critical moments of the barley growing season contribute to adverse quality, manifested in corn size, lower homogeneity, and increased protein and xylanases, making brewing more difficult. Are there initiatives in place to develop varieties that can withstand these, for example, hot, dry springs or high rainfall at harvest time? So I think we're looking at varieties that are more able to tolerate variation in climate.
Yeah, I think the simple answer to that is yes. I think we're all well aware, that we are living in a changing climate, and we need to adapt our cereals to meet that climate. I know there is a lot of work going on looking at, almost looking back to the Fertile Crescent area for variety and for germplasm and for genotypes, which may well bring forward some greater drought tolerance. It's hard to see that we could have a variety that could be drought tolerant and flood tolerant in the same genotype. That might be a challenge. But we are seeing much more variable weather patterns at the time of harvest. So fortunately at the moment we're dry here, but quite often we'll see the UK winter barley harvested in good conditions in July, and then quite frequently we'll see quite heavy rain in August, which can have a significant effect on the harvested quality of the grain. So I think this is something that everyone is very conscious of.
Okay, I've got a couple of comments that are coming through on the chat. People can read those. And I've got a question. In terms of food safety, is it DON, so deoxynivalenol, and associated metabolites, or any other mycotoxins that should be reduced or eradicated? In terms of parts per million, are we talking about 1 ppm or lower for malt? That's coming in from Zanna Zehet at Bowmill, Sweden. So just a quick comment on mycotoxins, David.
Yeah, quick comment on that. So certainly, field mycotoxins. So we've got legal limits. We've got maximum residue limits on deoxynivalenol. We've got it on zevallenone. We've got some advisory limits around T2 and HT2. So we can't accept grain above those legal limits. In stored grain, we've got the risk of ochratoxin A development, and we've got very low limits on there, which are down in the part 3, 5 parts per billion level. Deoxynivalenol is 1250 parts per billion, so just over 1 part per million level. I mean, the good thing is we have a very good washing process at the part of our process. I think one of the key undertakings that we do as part of the MAGB due diligence scheme is to monitor residues on barley going into process, and we monitor residues on the malt which comes out the other end, so we can directly tie the levels on the barley to the levels on the malt. And looking at those, we see very little. If there's any evidence of deoxynivalenol on the barley, we rarely ever see any of it on the malt. We've done a good job of washing those residues off during steeping. So yeah, but we do need to continue, obviously, to drive those in. Some of this is out of our control. Weather conditions play a big part in the formation or the likelihood of mycotoxin being present, fusarium contamination.
Yeah, I was going to say there's more information on the MAGB website and also on the website of many of our malting company members. I've got one question here, which I think I will make the final question, as it's an interesting question. So, best way to reduce carbon footprint in brewing would be to remove the malting process entirely in favour of high adjunct brewing and artificial exogenous enzyme addition. Where do you see the future of malting?
I'm not sure I would agree with that comment, not only as a maltster, but also the fact that you've still got to grow the barley. And growing the barley is currently where you've got a massive 60% of the carbon footprint of malt comes from the upstream scope 3 emissions. So the actual malting process emissions are relatively small. So I think if we can get our agricultural emissions under control, then I think malting will continue to be the predominant way of providing raw material into our distillers and brewers.
That was absolutely where I was going to go, and I think that really is a great advert for our next seminar, which is looking at sustainability of barley and malt, and I think that question will be adequately answered. And on the quality side, there really is no substitute than good quality malt.
Absolutely.
Okay, I will finish there. And I was just going to say, David, thank you very much for your time. And that was an extensive topic. And thank you to the Barley Hub for hosting the seminar. And thank you to everybody for attending. And there's a link on the chat for the next seminar. And I know it's a hot topic, probably the hottest topic actually in the sector at the present time. And I can't think of a better speaker to give that. So thank you for everybody for attending.
Thank you, everyone.
Thank you.
And see you next time.